Greetings, Panthers. Dr. Augustine. Hope you all are doing well. And today we are going to tackle the last major topic in Chapter 1. This is coming from Section 1.8, dimensional analysis, sometimes known as the factor label method. Depends on the book or the website that you're reading. Either one of those, you're talking about the same thing. And I'm calling this a key concept here because this is really one of the driving concepts in Gen Chem 1. If you fail to learn how to do dimensional analysis, you are going to be very hard-pressed to be successful in general chemistry. And I'll give it in a more positive way to say, if you develop the correct systematic way of doing it, problems that seemed very difficult to begin with become much easier. In fact, if you can use the units, so dimensional analysis means using the units to switch from one thing to another. So using the units allows you to convert from one thing to another. So what we're going to do today is I got a bunch of different examples, 7 different examples, and this is going from sort of easiest to most difficult. And I want you to pick up on a couple of ideas. And the way I would recommend that you watch this video is when we take on each individual one, you should just stop the video, work on it, see if you can do it on your own, and then come back and show me solving the problem. So what we're going to do here is we're going to use our units to guide how we do these calculations, do these conversions, and I'll show you a technique or a trick for doing that. I want you, before you start typing numbers into your calculator, to try to develop some sort of conceptual plan based on unit canceling. So this is a really important idea. You want to sort of have a strategy when you look at these problems to figure out where you're going. So you want a conceptual plan based on unit canceling. And then we're going to tackle 2 specific things at the end that students tend to have the biggest problems with. Raising units to powers, in other words, squares and cubes and stuff like that. And that comes into play specifically in things like volume and area, because those are squared and cubed units. So students typically have problems with raising units to power. I'll show you how to address that. And then density problems, students typically have problems with density problems, and a lot of that is because there's a volume term in density. Remember, density is mass per volume. So because there's a volume term in density, they'll mess things up with raising them to powers. So let's take a look at 7 different problems, and we'll take a look at number 1. Again, this is going from simplest to most difficult. And again, my suggestion is to maybe at this point stop the video and see if you can convert 0.127 inches into millimeters. All right, and while you're taking a look at that, I will switch pens and switch colors. So the conceptual plan in this case, I always like to say, what am I starting with and what am I trying to get to? I'm starting with inches and I'm going to millimeters. And then I also like to say, what information do I have? Well, I have a conversion factor here. I have the conversion from inches to centimeters. This particular conversion, 1 inch equals 2.54 centimeters, turns out to be an exact number. This is not an approximation, it's an exact number. So these are actually infinite number of sig figs. But given this information and given what we have, your conceptual plan is going to start here with inches, and you're going to say, all right, how do I get to millimeters? Well, if I get to centimeters from this conversion factor that I have, and then I can go to meters, and then I can go to millimeters. Now, I know some of you are able to make this conversion in your head. You know the difference between a centimeter and a millimeter. You know that there's a factor of 10 difference, no problem. I'm going to encourage you to go through the base unit on these calculations unless you really are confident you know what you're doing. So in this case, the base unit is meters. So I would go from centimeters to meters, then from meters to millimeters. Just get in the habit of doing that. Centimeters to millimeters might not be a problem. Picometers to millimeters might be a problem. You may not know that one right off the top of your head. If you go through the base unit and you've memorized that table that we talked about a little while ago, then you shouldn't have a problem doing this. All right, so how do we actually attack this problem? So we always start with some information that we have in the problem, which in this case is our starting number, 0.127 inches. And now I'm there's a couple different ways you can do this. Probably the easiest way that students seem to like is this sort of railroad tracks method. And if I have the units in inches on top, I need inches on the bottom in the next one. In other words, that inch needs to cancel inch there. So now I need a conversion factor to take me from inches into some other unit. And we already said that that conversion factor is going to be 1 inch for every 2.54 centimeters. All right, because I've crossed off the inches, if I was to just do this calculation now and stop, my answer would be in centimeters. All right, but I don't want to be in centimeters, I want to be in millimeters. So I am going to go to the next step, which means I need centimeters on the bottom and meters on the top. I'm going to go to the base unit. Now remember, my table is 10 to the minus 2, and I always put that on the base unit. So 10 to the minus 2 meters for every 1 centimeter. And now centimeters cancel centimeters. And now I'm going to do the next step, which is I'm going to try to cancel that meter off, and I'm going to have millimeter on top. That's 10 to the minus 3, and remember that always gets applied to the base unit. 10 to the minus 3 on the base unit. Okay, so if we do that, meters cancels meters, and the last unit that I have left is millimeters, which is what I'm trying to get to. Okay, and now you can get out your calculator and actually do this calculation, and this calculation is 3.2258 millimeters. And at this point, we have our number that shows up on my calculator, but now we need to find the right number of significant figures. So we go back up to this calculation, we look at each of the factors and say which one, first of all, is this multiplication or division or addition, subtraction? And we know it's multiplication, division. And so the rule is we want to have the least number of significant figures of any one of these individual calculations. So there's 3 significant figures here. This looks like 3, but it's really infinity. Why is it infinity? This is an exact number. Okay, this one is also infinity. This one is also infinity. Therefore, my answer should be 3 significant figures. So I'm going to round this to this decimal place, which means I need to look at the next decimal place. And because that's a 5, I need to round that up. All right, so 3.23 millimeters. That would be my correct answer with the correct number of significant figures and with the units written down. Okay, so that gives you the general idea how we attack these problems. We start with a number, we start with some initial piece of information. If you want to do this railroad track method, this is a fine way to do it. We're going to cross off the units as we go, so I know I need inches in the bottom, and I'm going to find a conversion factor which allows me to cross off those units, and then I'm left with one set of units at the end. My last step is to find the number of significant figures. All right, let's take a look at the next one. Convert 5 days to seconds. And we're going to use our strategy here. So my units are in days, and I'm trying to get to seconds. And now I need to think about how would I do that? Well, let's see. I don't know how many seconds there are in a day. It's going to be a big number. But I do know that there are 24 hours in a day. So I can go to hours, and then I can go to minutes, and then I can go to seconds for minutes. All right, so my problem is going to look like a starting number, which is always in the problem. So 5 days. Draw out my railroad tracks. Days have to be on the bottom. So 24 hours in every 1 day. And I need hours on the bottom of the next step. Remember, I'm going to cross these off as I go. Hours are going to cross off hours. So how many hours are there? In an hour, there's 60 minutes. And then minutes on the bottom, seconds on the top. So there are 60 seconds in every 1 minute. And again, going back and checking, crossing off the units, and then looking at what's left. The only units that are left are seconds. I'm trying to find seconds. So this is the correct way to set this up. All right, and if I do this calculation, this is equal to 4.32 times 10 to the 5 seconds. 3 significant figures here, infinite significant figures, infinite significant figures, infinite significant figures. So I need to have 3 significant figures as my answer. Okay? 2 problems down, basically the same general idea. The trick is to come up with some sort of strategy. How do I get from this unit to this unit? And then you have to start thinking in your head. Days to hours to minutes to seconds, inches to centimeters to meters to millimeters. All right, problem number 3. $2.15 per gallon, that might be the cost of gasoline, that's what it is right now, to dollars per liter. What would the cost be in dollars per liter if we were to convert this? And I have that 1 gallon is equal to 3.785 liters. Okay, so I have a starting number. Dollars per gallon, and I want to go to dollars per liter. So if I want to use my sort of strategy, dollars per gallon, and I'm trying to go to dollars per liter. All right, now if you look at this, this is one thing I think another area where students sometimes have a problem. This is when you say something per something, dollars per gallon, dollars per liter, that means dollars divided by gallons. Okay, really there's a unit that has dollars on top on the numerator and gallons in the denominator. Well, you can convert the numerator units separately from the denominator units. We'll do an example down here that looks like that. Dollars, but if you notice, dollars actually stays the same. So I don't need to do any conversion of the top unit. All I need to do a conversion of is the bottom unit. I need to go from gallons to liters. And looky here, I have a conversion from gallons to liters directly. So this should not be a hard problem. So we're going to start with our $2.15 dollars per 1 gallon. Make some railroad tracks here. And now I'm trying to get rid of this gallon. So now I need to put gallons on the top, not on the bottom. Okay, this is a little bit different than the prior problem that we did, but I'm trying to get rid of gallons, right? So I need to put gallon on the top to cross that off, and I'm going to have liters on the bottom. So I'm going to have 3.875 liters on the bottom for every 1 gallon. And if we take a look at the units that are left after we've canceled them, I have dollars on the top and liters on the bottom. Those are the only units that are left. So therefore, that's all. Those are the only steps we need to do in this calculation. It's actually a 1-step calculation. So this turns out to be 0.568 dollars for every 1 liter. Once again, we should check the sig figs. 3 sig figs on this, 4 sig figs on this, but because there's only 3 here, the one with the least number of significant figures determines the answer. So it's $0.568 per every 1 liter. Okay, let's pause for a second and take a look at the next problem. We're doing a conversion in currency. So 150 US dollars into South African rands, and the abbreviation for rands is ZAR. That actually has to do with Zood means South, Afrikaan rand. Okay, so ZAR is the shorthand name for rands and USD for US dollars. And if you looked up on the web an exchange rate, you would find on the day I did this, it was 1 US dollar equals 17.2624 South African rands. Okay, so let's take a look at this conversion. So our strategy is going to be USD to South African rand, and we look on our information that we have, and I have a direct conversion, USD to ZAR. So this is going to be a 1-step calculation as well. You can actually tell how many steps your calculation is going to be based on how many steps it takes you to get from your starting point, days, into seconds. Well, it's going to take me 4 steps to get there. I end up with 4 steps on the railroad track. This one took me 4 steps. It also took me 4 steps. This guy here only took me 1 step, and I was able to do that conversion in 1 step. All right, so this one, US dollar into ZAR directly, that should be pretty easy because I've got that conversion factor. So this is going to be $150 US times 17.2624 South African Rand for every $1 US. I know these are a little bit weird with the dollar sign, but USD will cancel the dollar sign, and that will leave me with South African Rand as my last unit. And if I do this calculation, this is equal to 2589.36 ZAR. Okay, if we're going to follow the rules of significant figures, this does not equal the rules of significant figures. I should only have 3 significant figures from this calculation. Technically, this is ambiguous with a 0 here. This would be better if I had a decimal point. Then I would know that I actually meant 150, not 150 or 160 or 140. But let's pretend there's a decimal point there. So I have 3 significant figures here. I have 1, 2, 3, 4, 5, 6 significant figures here. My answer should have 3 significant figures, which means it needs to be to that decimal place right there, which means the number before it is going to influence it and is in fact going to round that number up. So this should be 2590 ZAR. And a better way to write this, again, this is confusing, this 0 here. We don't know what that actually means. So a better way to write this would be to use scientific notation. So I'm going to write 2.59 times 10 to the 1, 2, 3 South African Rand. Okay, there's an unambiguous answer with the correct number of significant figures and the correct calculation. Okay, all of these are pretty straightforward. If you want to stop this video for a minute, take a look at the next problem. The next problem is more challenging, and you might want to take a few minutes trying to work on this. Meanwhile, while you do this, I'm going to erase this other stuff that I've written. Okay, I'm back, and this one asks us to convert square kilometers to acres. Acres is a measure of area, usually of property or something, size of a field, size of a city, something like that. And kilometers squared would be a unit of area. And the conversion factor I have is 1 acre equals 4,046.9 square meters. So anytime you have a square, that's a measurement, a square of a length, that is a measurement of an area, okay? So if we want to start thinking about this conversion, we have kilometers squared, what we're starting with, and we're ending with acres. But I do not have the conversion factor from acres directly into kilometers squared. I don't have the conversion from 1 acre equals so many kilometers squared, but I do have meters squared. So I can go to meters squared, and from meters squared, I should be able to go to acres. Okay, so using this strategy, this tells me it should take me 3 steps to do this in my calculation. So we're going to start with the number that we have initially. We always have a starting number. So my starting number here is 0.465 kilometers squared. Draw my railroad tracks. And I'm going to need kilometers squared on the bottom in order to cancel off kilometers squared. But I don't know what the kilometers squared to meters conversion is. I know what the kilometer to meter conversion is. So I'm going to erase this square mark here and redraw the lines I've just erased. So I know kilometers to meters, and I know that there are 1,000 meters in every kilometer. So remember, that factor gets applied to the base unit, 1,000 meters for every 1 kilometer. And if I want to get out my red pen and start canceling, I can't do it yet. And the reason why I can't do it yet is this is kilometers and this is kilometers squared. So I can't cancel both of those off. So there's 2 ways I could do this. The simplest way mathematically, to express this is to square this entire factor. Okay, I need to square that entire factor, which means I need to multiply 10 to the 3 times 10 to the 3. Now look, this is a really common mistake that students make. I'm going to write it out more explicitly. Sometimes students like to write it this way just because they're less likely to make a mistake. You can write it either way, whatever way works for you, but you need 10 to the 3 meters for every 1 kilometer, and then I need another 10 to the 3 meters for every 1 kilometer. Okay, and now kilometers times kilometers is kilometers squared. That will cancel off kilometers squared. Obviously, a simpler notation is to just put this whole thing in brackets and square this entire thing, but it's the same thing as doing this. Okay, now I have my answer in meters squared. Meters times meters is meters squared. And now I need to get rid of the meters squared, and I need to convert into acres. So now I'm going to have meters squared on the bottom and acres on the top. And in this case, it's 1 acre equals 4,046.9 meters squared. And now using my red pen for crossing off units, that meter will cancel off that meter right there. And if I was to do it in the other brackets, I would say 0.496, oops, 46.9 meters squared. So then I could do meters squared cancels meters times meters. And being consistent with my prior thing, the last units that we have left are the units that are going to be on my answer. The last units I have left in both of those is acres, and all the other units have been canceled out. Okay, and if I do this calculation, this turns out to be 112.6788 acres. And now I need to go back and check sig figs. So there's 3 sig figs right here. There's an infinite number of sig figs right here. There's an infinite number of sig figs right here. And there are 1, 2, 3, 4. There's 5 significant figures on this. That means this is the limit. So I'm going to have 3 significant figures on my answer. So I got to come to this answer and say that's where the sig figs are. And then this one is going to influence that. I need to determine whether I need to round it. It's greater than a 5, so yes, I do have to round it. So 113 acres. So one way we could express this is 113 with a decimal point, or I also could say 1.13 times 10 to the 2 acres. Either one of these would be acceptable answers with the correct number of significant figures. You notice every single time I'm writing down a unit and a number. Almost every answer in chemistry in a calculation is going to have some number and is going to have some units with the right number of significant figures.